Hello everyone. Today I want to cover an indicator that I set up a couple of years ago, intended for scalp trading, which involves trading very small price movements, typically in high frequency trading. The indicator will predict every second, using historical data, say in the last 5 minutes, to predict if the price will go up or down in the next, say, 30 seconds. It's inspired by this paper, which you can read by clicking on the link referenced. I've been wanting to make this video to remind myself what was done, the learnings and the challenges that I faced. After getting questions on this from people I've never met, I also hope to provide at least a bit of documentation and insight to anyone who might find this interesting or useful and want to take the idea one step further. This indicator is created using Orderbook data collected by another bot that I created and trained and validated using a convolutional neural network model, and then using the trained model to predict if the prices will increase or decrease in the next, say, 30 seconds. The predictions are done in JavaScript so that it can be more easily integrated into a web app where we can show predictions live in the browser by calling the exchange's Orderbook API. What's a convolutional neural network? I will try to explain at a high level based on my understanding. And it's a type of deep learning algorithm that is very popular for image recognition. Consider the most primitive neural network. You could feed each color parameter of each pixel of an image into the network as nodes, apply as many layers as you want to allow for nonlinearity, and fit the weights. But that's just not practical, as you'll be dealing with more than, say, trillions of nodes and weights. And it's also not accurate because there's a risk of overfitting to the sample you use to train, and it will be hard for the model to generalize. The convolutional neural network approach takes kernels. Think of the lens of a microscope in front of an object on image. These are the squares you can see in this illustration, basically an n-by-n matrix with some values in it. Then you move it over an image and convert, transform, and summarize its values using matrix multiplication, essentially downsampling the input data to output in a very long linear way. The weights in the kernel are trained, and you can apply several kernels to the same image to increase the Z dimension of the layer. General practice as shown here is to convert or reduce the dimensions of the original input, 28 by 28, down to a single dimension while increasing the channels over the layers, so that eventually you end up with a flattened set of nodes to carry out a limited number of fully connected layers for fitting the weights for the prediction. The design of the network, the architecture and its components, how you set the so-called hyperparameters, all seem to be more of an art. For this indicator, as I'm not the expert, I've mostly relied on the hyperparameters and architecture based on this research paper on stocks, and I just made sure that I understood the design. What inspired me to implement it though in the crypto space is because the exchanges, all the books, are actually very accessible by the public. For this indicator example, I used Binance, which was already the biggest exchanges in the world in 2020, and the Ethereum Bitcoin pair being the most liquid crypto pair. And Orderbook shows market depth. It lists the size of the buy and sell orders, or rather limit orders, for the instrument organized by price levels. You can define the granularity of the price levels. So the idea is to test out if the shape of the order book can tell us anything about the micro movements of the trade prices. Intuitively, if you have a wall of sell orders, then the prices may be inclined to drop and vice versa. Although in this case, we just let the black box do its work. So we collect this data, feed it through a convolutional neural network, train the model, and use it to predict price movements. In part 2 of this video, I will go through the code and some of the details outlined in the research paper.